So today I'm going to talk about ProtaStructure 2019 SP7. We've been progressively introducing new updates to the platform. So the development in a way has evolved, and it's not just a case of us annually releasing a new version, or maybe with 1 or 2 service packs. We're now constantly developing and releasing new functionality into the platform as it evolves. So over the course of the last 3 or 4 months, we've actually introduced 2 or 3 major service packs, which have introduced a lot of new functionality that we've wanted you to start to enjoy. So I'm just going to come and start up the system and get in and show you a presentation. Today I'm going to try and show you as much as I can over the time that we've got. I think I'll end up talking for about an hour on the software, and I'll cover a range of different topics as we go. So I'm just launching the software, and when you do start the system, it will check to see if you're using the latest platform. If you are wanting to update this, it can update it seamlessly. But if you're new to the system, there's quick start guides. We've got online help, video tutorials that you can watch. We also have regular updates, as I mentioned, and they're all documented within the software, so you can easily get access to understand what's new. Now, when we start a project, I'm just going to come in here and give it a name. So we could call this global reach out. Give it a project name and then hit OK. So what we do is, what we've studied is different markets around the world, and we've created these what we call project templates here, or design templates based around different markets. So if you're doing projects in, say, the UK, maybe Ireland, or perhaps you're doing a project in Malaysia or Singapore, you can grab these templates, and these follow the local design and detailing practices of those countries. You can also create your own templates, so this is not hard and fast. You can come and adapt these to suit the way in which you want to present information. What the templates do is they standardize the way design and detailing is done. So I'm gonna actually choose something a bit different from last week. Last week I did a Eurocode template. Today I'm going to look at the American codes, and we'll use the Philippines template as an example. So when we do this, the local codes of practice will be loaded, and then you can then get straight into the modeling environment. Now, when you are in the modeling environment, you can start in different ways depending on the information that you have. So if you have an architectural drawing, you can import this. Maybe it's a layout plan with grid lines and so on. You can extract information from this. So you can pull off grid lines, columns, and the like can be extracted to help you set up the model. If you have information from BIM, maybe Revit, basic Revit information, this can be imported as well. If you have large projects, maybe you've got a big tower with a podium, you can actually break these projects into components, and then you can combine them. So if one project member is doing the tower, another one's doing the podium, you can split these up and then work on these independently, and then later you can merge these together. That just all aimed at saving you time with setting up and establishing models. Now I'm just going to quickly create a layout here and a model for you to look at. Okay, I'm just going to key some grid lines in here, and you can just happily go in and just key an arrangement. Maybe I've got another one, say 6, and then 2. So you can just key in a grid line arrangement here, and you can see that these axes are set up in the model. Now these are all dynamic. You can work with these axes to make changes. So if I decided that maybe this grid line I don't want to work with a straight grid line, but maybe in this instance here, I'd like to create something that's perhaps curved. So this is all dynamic in here, and you can make changes. So I can key in maybe a chord length, and then it will draw that axis perhaps the way I want it. If you wanted to make other changes, perhaps you've got a really unusual facade or something a bit different, then you can use what we call linked axes, which are dynamic, where you can just come and create whatever funny layout the architect might have set up. So in here you can see I've just come in and manipulating this, and I can just draw out the exact layout that I'd like to have. Now I'm going to work with physical objects, and I'm going to start placing these in the model. So the first thing I might do is create some columns. So let's just click and insert a column. I can box around to create multiple columns. Okay, if you've got columns that may be orientated in different ways, then these can be set up here as well. So you can just come in and orientate these how you please. So I've just set those up and I've orientated those columns along the curvature of that grid. Now we work with libraries, and within libraries you have different elements, different physical elements, properties here that you can use to create the model of your choice. So if I'm working with concrete in here, or maybe I'm working with built-up sections or steel libraries, or even cold form, or even composite sections, these can be created within the model. So I might want to grab, say, a circular column, and if you type in the properties of that, say 500 diameter, we will calculate the underlying engineering properties for you. These can be edited, and you can adjust stiffness properties locally as well as globally. So if I then want to use that in the model, I can just take that, and then we can just come and work with that around the edge of the model there. Now I'm going to come and create my core walls, and I can just easily come in here and put in some core walls, and we can, or wall systems that we want to use in the model. And I'm also going to come and put in some beams here. So let's just make it a, say, a 650 deep section, and then we can just box around to create the member. Okay, so you can see here I'm just boxed around to set those up. I can just click between points and it will put them in as well. If you have situations here where maybe you want this beam to crank, okay, or maybe I'd like this just to snap to that point, okay, you can just run around here and lay this out the way that you'd like to see it. I've got a curved beam there, I can easily come and create that. I'm also just going to come in and box around and put a number of members in quickly. So you can just have these tools to help you lay out your plan views very quickly. I'm just going to put another member in there. You can see I've just pulled this through. I don't need to worry about overlapping. We know that this wall and beam exist already. So when I do create this, it understands that, and we'll just put those extra members in. Now you can see here when I'm overlaying this, if I just mouse over a member, it picks up handy points. So quarter point, third point, midspan, and we can snap to these points to just come and create the maybe the secondary elements here very quickly. If you have a particular distance, if you hit F2, you can type that distance in exactly, and then you'll get that point, and you can then get other handy points like the perpendicular. Now, once you've got these in, you can actually move these around. So you can see I've just adjusting these. Maybe I've got some architecture underneath where I just want to adapt it to suit easily. Quickly, you can just come and make these changes as you go. Now, I could do that for individual elements or grouped elements. Maybe I've got a few columns that I want to tweak. I can do that as well. The other kind of handy things in here you can do is if you're wanting to fix set out. So maybe I want to actually fix that beam line. You can also make use of anchor edges. And if I set up an anchor edge there, you can see that I'm now anchored that edge to the side of the building. Now that might be a facade and I want to keep that position. Maybe later in the project there's some changes and I want to change the size of the member. Maybe I made that 350. You can see it's kept that position, it's just made that beam wider on one side. So there's tools like this that you can make use of within the software to help that process. Same thing can be done with columns if I wanted to just move a column into a different position. And then maybe as part of that, if I go to the column properties, or I can come in and set up anchors there. Maybe I want to anchor the corner of that column. If I decided to change the column later, it became 300 by 600, say, then you can see that that position's fixed in place. So they're just some handy tools that can help you with setting up the layout of your members. At this point in time, let's go in and just create some slabs. Now, you can work with load libraries to help you develop loading within the slabs. And in here, I could come in and let's just create some loads. So if I've got different parts of a building, maybe I've got a bedroom and perhaps a bathroom. So in here, I can work with load libraries to help me define different types of finishes, and I can use this to help me quickly build up things like my superimposed dead load. Now you can color code these. You've got a range of different colors there. You can just choose to highlight them in the model. And if it was a bedroom, for example, I might have a screed finish that's maybe it's 45 thick, and on top of that, I've got maybe some marble or mosaic tiles, or maybe I've got some parquet flooring. So you can key the properties in here, and it will calculate the self-weight. Now the materials can be edited. You can build up your own libraries of these. The same thing applies to shear walls, brick walls, and so on. You can do the same thing here and build up different finishes, and then we can use these in the model. So maybe for the bedroom, I've got a different type of finish, and again I can just key the thickness in, and key in the appropriate properties here. Maybe it's some tiles. Okay, we can just work with those and create those. Now the other nice thing is that later on in the project, if there's some changes, I don't have to go and change every slab. You can just come in here and edit them. So if the architect changes his mind during the course of the job, you can come and edit these, and your finishes and so on can update floor by floor or globally. You can just come in here and easily adapt them. So it's a nice way to be able to manage changes when they occur. So if I come in and create my slabs here, we can key in the thickness. Those finishes that I set up here are available in the library, so I might have a bedroom. And if I'm not, and then I can key in the live load, and then we can come and create that within the model. Okay, so here I can see I've just created some slabs there for my bedroom. Maybe I want to put in my bathroom. Maybe my live loading is a little bit higher, so we can just come in and choose where they are. Of course, you can clear any loading that you like in here. So if you're wanting to put in other types of loads, then these can be included in the model. So I might have a higher imposed load here and finishes, or maybe I want to put in something a bit different again. Okay, all of this can be adapted to suit. Okay, so you can just run around and create those. Now, if I've got unusual geometry, we can also make use of what we call sketch lines. So you can use these to help you sketch out a profile. So if I had maybe the side of the building, I've got a funny slab, and I can use sketch lines just to help me sketch this profile, and then we can use this to help to define that element. So I might want to put in an edge slab there. We can key in the thickness of this. Maybe I want to drop it, maybe 100. And then I can use that boundary just to help me create that slab. And you can see the loads being distributed there. I can change the symbols to suit the way it's spanning. That can also be looked at as part of the analysis and design. Now, before I get too far in the project, I might just want to come and check things. So I'm just going to come in, and to do this, I'm going to look at the visual interrogator. So that's just available in the tree here. And if I just want to quickly come and check, okay, what column sections have I used in the model? Maybe what beam sections I've employed. Maybe I'd like to see what my live loading is, or perhaps my dead loads. So all of this you can easily interrogate from the model, and you can just check things before you get too far. And there's other things in here that you can look at as well: wall loading, integration status. There's all sorts of material properties. All this can be reviewed in here. So you can. That's a nice tool just to catch things before you get too far. Now, I'm also going to look at some other things that you might want to do within the model, depending on the nature of your job. So in here, we can work with different elements to make changes. And one common thing might be that you've got very unusual geometry, and maybe the architect's working with unusual shapes in your columns. And we can use things like polyline column editors to work with these to allow you to create whatever it is that you like. So here I'm just drawing up a profile of perhaps a column that I want to look at creating. Okay, and this could have openings and curves and so on in here. We can then use tools within this to help us contain out these shapes. So I'm going to use some automatic containment, and it's automatically putting in reinforcement around the perimeter there. Now I can work with this as well. So if I decide that maybe I want to add in some extra ties in here, okay, I can just come in and create these using the polyline column editor, and I'm just creating some extra links there. I can also come in and create extra bars. So if I want to use this as a template for then designing this arrangement, I can. And you can just run around and just set this up to suit. So you might want to add some extra bars in there. I could extra ties, my openings and the like. Now, if I'm happy with this, then if I hit OK, then that's returned to the model. And we can then, it will then use that as a template for the design when we get to looking at that element. Now, similarly with the walls, if I just come in and click on this main core wall, I can actually come in and merge this. So this can become a single element. And in here, we can come and work with the walls to create different types of templates that we might want to work with. So I can ask it to automatically contain, but you also have the ability to be able to drive this yourself. So one example is that maybe I want to come in and define some end zones here. So if I just right click, we can come in and choose to insert an end zone link. Sorry, let me just do this again. Okay, and you can see here that I can play with the end zones here. So if I just click on this, it will give me some options to be able to work with this. So if I was wanting to then go in and create a custom arrangement for the end zones here with different bars in here, I can. Okay, and then this can be then used to drive that. So if I had OK, you can see that we've automatically created some end zones there. At the same time, if I just go back and click on this, I could just put in another link, okay, and you can see that I've created some containments along that wall. Now you can drive this as well if you want to put in additional sidebars there, okay, to work with. You can do this also. So you can create your own custom editing of this merged wall. Now I'm just going to delete these at this point. We can also work with automated containment of this, and it can try and find containment arrangements for the walls as well. So you can see here it's proposing a containment arrangement, okay, and again you can work with this and adapt this to suit the project that you're working on. So there's some quite powerful tools in here just for working with these types of things before we get into the design and detailing. Okay, now I'm doing seismic design, so I am going to just unmerge these walls because I want to look at a specific detailing relating to seismic. I'll come back to this later. But at this point in time, I've been creating a plan view. I now want to have a look at this in 3D. So what we've been doing, we've been working in plan, creating what would be like a key plan, but actually we've been building a 3D model at the same time. So you can see this model here in 3D. And I can look at both plan and 3D views here, and I can continue to work with this. So if I'd like to at this point, maybe I want to come in and put in some beam wall loading. Again, you can choose from libraries here. So if you've got certain types of brick walls that you want to use, you can grab those from the library. A bit like the slabs, you can build these up. I can then take these and copy them. So I can copy the beam wall load there, and I maybe want to choose to copy this around the perimeter of the building. So here you can see I'm just selecting some members at the edge here, and it's simply a case of copying and pasting, and you can see that they've been applied to the periphery of that structure. And I could come and put some internal wall loading in as well. Now it's a physical model, so other things that you may come across within a project, you might have things like openings that you want to define. You may even have things like drops that you want to put in within the project. So all this can be set out within the model, and you can use tools within the model to create these objects. Okay. You can also define other things like loading on slabs, wall loadings, and the like. These can be entered in, and you can just if I just create these, you can visualize those in the model, and you can see exactly what you've created. Within this model, you may also even want to put in things like openings and shear walls. All this type of thing can be done. Now at this point, I might want to start to take this information and start to replicate it up the building. So I might have a 5-story high building, and we can just hit OK, and you can see that placeholder has been created. Now, when you create placeholders for floors, you then have the ability to be able to work in any floor that you like. So here you could see I could just come in at this point and start to work at the roof level here. If I wanted to come in and put in elements and objects, I can. If I've got sloping members, if I've got things like landing beams, all these can be created as you go. So you can work in both 2D as well as working in 3D here. Now, of course, if you don't want these, you can, of course, just remove them and then get back to our basic model. But that just gives you an idea of how flexible this is. Now, if I come back to the first story, I'm now just going to come and generate this information up. So I'm going to copy these elements up the building. And if I just hit OK, you can see that that's just replicated those floors up. Now, at any point in time, you can make changes in here. So if I want to remove a beam or a slab, I can come and do this. You can see there at the roof level there, I may at this point just want to maybe I want to delete the wall loading on that roof. So I can just come in and remove that, and instantly the model's updated to reflect that change. Now let's go to the roof, and I'm going to work in 3D with the roof. So you can just adjust the images to suit. You can see maybe I want to make the 3D view more prominent. All these types of things can be done. let's just come in and at this point create some columns. So you can work with different sections in here. You might be working with American sections or maybe British sections. You can mix and match in here depending on the project. So if I just grab a column section in the model, I can then just work to create that in the roof plane there. So maybe I've got some columns along here that I want to put in. Now, some steel elements. Now, for steel work, if you're wanting to establish things like trusses, you don't need to key the coordinates in. You can just snap between points, and we will enter you into a library where you can start to create and define different types of trusses. So whether they're straight or maybe they're curved, okay, or out of plane curved, you've got different profiles here that you can choose from in terms of creating trusses of your choice. Now these are very flexible. You can adapt these, all these dimensions and so on are adaptable to suit. If maybe I want to create a few extra bays, these can be done here. Okay, and you get to see or preview what you're creating before you create it. Now the members are grouped, so top and bottom chords are in groups, diagonals are groups, and you can just come and adapt these to suit. So if you wanted to change this to maybe back-to-back angles for the diagonals or the verticals, you can come and change these. Maybe you want to use channel sections or tubular sections. It's up to you. You have full flexibility to control this. So if you're happy with this, if you just hit OK, that then gets created. And the truss then becomes available to use elsewhere. So I can just copy this and replicate this across the roof of the building there. So you can see I've just quickly come and created those additional frames. Let's put in some other steel members here. I'll just grab maybe a UB and we can work with this in the model. You can play with things like fixity. So if I want to maybe pin both ends of a member or pin one end or the other end, you can just establish that control. And I'm just going to come and create those peripheral members there. So you can see I'm just snapping in 3D to create those. As I mentioned earlier, you've got intelligent snap points. So if you want to snap to other parts of the structure, you can to create unusual geometry. So let's just come in and put in my apex tie beam there, okay, and then you can see that I've set those out. Now, at this point, I may want to look at maybe bracing the structure because obviously I don't want that roof to fall over. And we can come in and define our bracing systems in here. There's different types of braces that you can choose from. Okay, you can see V brace, K braces, and so on. And these are all adaptable. So if you want to move things, you can. You can see that I've adjusted the position of that brace. We've left the analysis model centerline, but again, you can also move that as well. So you have flexibility here just to adapt things to suit the project. I may, for this element, maybe I want to use a tubular section, and we can just come and choose something that we might think is appropriate there. Okay, and you can see that it's been created in the model. So if I'm happy with that, just hit OK, and you can see that that brace has now been established. So we can just quickly look across the roof and then define our bracing arrangements. Now, the last thing we might want to do in here is we may be interested in design economy, so we may also want to define things like our purlins and girts. And to do that, I can just click on two of those end bays, and it's predefining an arrangement of purlins here that I can consider. Now I can change this if I want to. I could type in my own spacings. Okay, you might notice here that I've also defined the sag rods. I'll just remove those to keep it clean. And I may also just want to play with the sections that I might want to start with. I might want to use a column section or something. I can do that. So if I hit OK, the purlins go created. I can add additional loads to these as well if I wish to. Okay, but that just gives you the idea. Now the final thing I'll do with this simple model is just to, at the roof here, is just to run around and let's just put in some girts. So I can play with the spacing of these, okay, and then let's just come in and set these up, and if I just hit OK, then they're created as well, okay. Now the important thing about what we've been doing here is that we actually are working with physical objects. So if you see the way that we've laid out the steelwork there, you can see that the purlins are sitting on top of the truss, the girts are on the face of the columns there, or will be connected to the columns, and the braces are in the plane of those bays there. So this physical layout or set out is very, very important to the software, and this allows us to then drive the design and detailing processes, as well as provide intelligent communication with other platforms. Now, at this point, I'm just going to change, and I'm just going to drop down at this point down to first story level. I'm just going to make some changes here as well. So if you want to adapt the model as you go, maybe you want to do things like offset axes, you can. In here, I can work with grid lines just to change them. So I'm add an extra grid line there, and I can create a few extra axes as we go. So I might want another one at say 6. Okay, and you can see that those grid lines have been created. Now I'm just going to grab these two grid lines here, and let's just stretch these. So I'm just pulling these out. Now I'm going to take, if I go back to the properties that we were working with earlier, I may come in here and maybe I want to work with, say, a composite section, for example. Okay, we could come in and just define a maybe a UC or something within the composite profile. Okay, you can play with grades of concrete and steel in here, but if I just hit OK, I can just then maybe use that in the model here. So let's just create those sections here. Okay, I'm also going to just come in and work with this a little bit. I just want to show you a couple of interesting things here. So let's just create in some beams. Okay, and I can just move through and create these here. Okay, so we might just define something like this. Let's also, I'll just put one more beam across the front there. Let's just place a beam here. And we could, at this point, maybe put in some slabs. It could be a precast slab, or it could just be a conventional slab. We can just come and work with this here. Okay, now you can see it's also understood that this is actually a one-way spanning slab, so that's been done as well. Now, I'm going to, at this point, come in and work with something called planes. So to use planes, we can just come in and define a plane, and then we can set that up. So I've just inserted this, a bit like inserting a slab. You'll see that there's different points here, 1, 2, and 3, and I can work with the plane to make adjustments. So if I decided that point 3 here, I want to drop this 1500, the plane 1500, I can define that. And if I right click on the plane, we can just move members to that definition. So if you're wanting to quickly create things like ramps and other unusual sloping geometries, the planes is a fantastic tool to allow you to do this. Okay. Now, at the same time, because I've set the plane up, I may want to go back to the slab properties, and I'm going to just choose that slab doesn't contribute to the rigid diaphragm, so that this would probably be properly considered within the analysis. You can't have sloping and rigid diaphragms meeting. So that gives you an idea about how we go about creating the model. Now, before I move into the analysis, I just want to point out a few things that we've done automatically as I've gone. Now, you might see here that there's intelligent yield lines being created. And what we've done here is we've automatically worked out the distribution from the slab, automatically working it out to the beams. Now, this distribution can be a yield line, intelligent yield line distribution, which is what I'm using here, or alternatively, you can mesh the slab and distribute loading based on that meshed elements. So it's very intuitive. All this is being done on the fly as we've gone about creating the model. Now at this point, I just want to move in and start looking at the analysis and design of this. So earlier I had loaded codes of practice here, and I'm using the American codes here. I've also used the local earthquake code for the Philippines, but there's other codes of practice here that you can choose from. So for seismic, I might be interested in using Eurocode 8 or IBC or UBC. I can draw from the library here. If I'm working with other codes of practice like the British standards, Eurocode standards, even localized codes like Hong Kong and Singapore, we can draw these from the design code selection. And we're continually adding to this. You're going to see more and more codes coming into the platform very soon. Now, I can also come in and customize the materials that I want to use before I move into the design. So here we can come and select different grades of rebar, different grades of, and the sizes that we wish to use here can be defined. If you don't have certain size, then you could omit those or include them. You can just customize this to suit the project. And we can now work through how we go about creating things like loading. So in here, I'm working with the NSCP for Philippines. So this is very similar to the IBC code. And we can come in here and just choose things like different seismic zones that we want to adopt, seismic source categories. So all the loading here I'm just stepping through the code and defining this. So for seismic, we have very powerful design capabilities, and this gets into looking at ductile design and detailing. For the Philippines, you can choose different occupancy categories for the building. You can also come and choose different systems here. So for dual systems with moment resisting frames, we will then produce the detailing in accordance with the code. So you'll come in and choose the appropriate system that you might be wanting to adopt, okay, and then the software will then go away and work with this. So I can have different systems in different directions, seismic resisting systems in different directions, and the spectral curves will adjust to suit. I can also come and choose different ground conditions, so whether it's hard rock or soft or stiff soils, and you'll notice that the spectral curves will adapt to suit. Okay, so these are all adaptable. If you do have your own seismic loading code, seismic loading spectra, these can also be imported as well. Now I'm going to run the analysis here. I can choose a number of modes that I might want to consider. Okay, so maybe for this structure I'll consider 12. We also will check for things that are very important to doing earthquake engineering, like irregularities. So planar, torsional irregularities, stiffness irregularities and elevation. These types of things the software will go away and check as we progress with the design. Now, if there are any penalties that are associated with these checks, these will automatically be applied to the analysis and design process. For seismic, we also do some other interesting things. We will scale the base shear results automatically against the RSA results. We will check for mass participation. And the other important checks will be for joint shear as well as strong column weak beam action. So these are some very important checks that are quite tedious if you're designing earthquake loading. So I'm just going to accept that, and that's done. Now, loaded combinations can be automatically generated. I'm generating my vertical combinations here, and you can create things like dead plus live combinations. Your pattern load cases can be set up here. But we can also run stage construction analysis if we're doing high-rise buildings. These can be done as well. For lateral cases, again, I can come and choose my seismic loading, okay, and I'm going to apply vertical earthquake. We can also come and set up some wind load cases here, which I'll also define. Now, if I wish for our vertical combinations, we could use cracked sections or uncracked sections. But typically for gravity cases, you'll use uncracked sections. And in the software, we also have the ability to be able to use cracked sections for the lateral cases. And so what this enables us to do is use different stiffness matrices and different stiffness properties for different load cases and combinations. So for vertical combinations, I can use uncracked, and for lateral cases like seismic and wind, I could consider using cracked cases. And the choice is up to me. I can decide. So if I hit OK, those combinations then get automatically established here. Now, if I'm just going to come out and I'm just briefly going to save the model. And the reason why I'm doing this is I want to populate all the geometry to allow me to then apply the wind loads. Okay, so the software is intelligent, and once it understands the layout that you've proposed, and I just need to save this, it will then allow me to set up the wind loading within the model. Okay, so I'm just quickly saving this, and I'll come back in and I'll show you how the wind loading is then applied automatically. So just give it a second here, and we'll be with you. So if I come back into the analysis, and we're just going to come and set this up again. So if I click on the wind loadings, you can come and calculate the wind load. You can come and choose your preferred code of practice here. So we have Euro codes, we have the British standard as well as the American codes. There's also a Malaysian standard, which is very similar to the Australian code. So in here, you can choose your preference here, and then you can key in basic parameters like basic wind speeds and so on. We will then automatically calculate pressures, and we will assign the loads floor by floor to the structure. Okay, so that's just done automatically, and I've now applied my wind loading, and that's done. Okay, at this point in time, I can then just move in and start to look at how we're going to analyze and design the structure. So earlier I told you that you can use crack section properties for lateral cases. For things like the American codes, we'll automatically adjust the stiffnesses here to align with the relevant code of practice. You can, of course, edit these if you wish. Okay, and those crack section properties will then be applied to those lateral cases that we had defined. I'm going to use rigid zones. I want a little bit more economy in my structure, and I can also come in and choose to mesh certain elements. So I may wish to mesh the shear walls, and I can define meshing parameters here if I wish. These can be set up, and I can also come and choose to mesh certain parts of the structure. So I may just want to, as a matter of course, mesh the first floor that we set up earlier. I can also choose to turn the diaphragm off for that. So I don't need the diaphragm for the first story. I'm just going to use a meshed element. Okay, and I can also play with the membrane stiffnesses here. So at this point in time, I'm just going to get in and run the analysis. And what we've done is we've created this physical model. I'm now going to move in, and from this physical model, we're automatically going to create the underlying analysis model. And we're going to move in and automate the corresponding design. So what it's doing now is it's just going to save the project, but you're going to see the analysis launch in a second. It's then going to move in and start the analysis process. The underlying analytical wire is being created from the physical set out that we've physical geometry that we've created. All the loading, everything is being automatically distributed, so that process is very efficient. And then it's going to move through and perform a number of checks as it goes. So if there's anything, any silly mistakes that you've made, the analysis will pick it up. Pre-analysis is also, you might just see up the top here, there's building model checks that you can perform to make sure you haven't made any silly mistakes. And that will also is a handy tool just to help you check your models before you get too far. So you can see here it's just moving through and running the analysis process. Okay. So it's preparing the data, and then this uses a sparse solver, so it's very fast and it's been streamlined for doing building analysis and design. So the data is prepared, it's just now running the analysis. If you just give it a few seconds, this will be done. And then post-analysis, you'll see that we are performing a number of checks. So we'll be checking for things like interstory drift checks, things like that the loads are being properly chased down the building and there's no loads missing, and things like deformations comply with relevant codes of practice. So the analysis is done, and those post-analysis checks are being performed. The seismic irregularity checks are also prepared concurrently, and if results need to be adjusted, then that will be done. So that whole process took about 50 seconds. And we do check for post-analysis. There's a range of different checks that are summarized in a report here. So that's done now. If I just close this at this point, it will then move in, and we've done the analysis. It's now moving in and batch designing all the elements. So you can see here it's just running through and designing the columns and walls. Now all the different combinations that I ran earlier, everything's being checked at this point. Okay, so we're checking for seismic, wind, all the envelope of forces or combinations that are required to be checked against code of practice is being done at this point. Now, what you may also notice that there are a few options here. So at the moment, I'm just pre-establishing our bar arrangements, and we will optimize the design for you. But I think you'll be aware that on any project, there's going to be changes that occur. And in here, we have the option to be able to keep reinforcement, keep design, and perform check design. So the software, so the idea is that you can just come and change the model, change things like loadings, and then you can update, you can rerun the analysis, and then you can just check the existing steel that you had. So these can be done. It's a really nice way of being able to track changes that occur. You don't have to redesign everything. We can then filter out those elements that need to be redesigned, and then they'll be done. So if you just give it a few more seconds, you can see it's just moving through and finishing off designing the beams. So I ran quite a number of combinations there, and that's why it's taking a bit longer to check than perhaps I would normally do. but I just thought I'd just show you this. Okay. So one or two more members, and then we can get in and start to look at the results. Now I'm just opening up, and I'm just asking if there's any questions. At this point in time, we are okay. People have asked if they can design to the American code. Yes, they can. Okay. Capacity design, yes, we're performing. Okay, and I'll come back to the questions later. But we're now done, and post-analysis here, I can come and look at the results. So I'm going to load the beta of the 2020 version, the post-processor. We've done a lot of work on this to just streamline the way that this works. It's significantly faster than the old processor, and you can overload this to review the model. So think of this as if you're looking at something like STAD or SAP. Okay, so here's all analysis results, and we can then come in and start to look at the results. So I may want to look at axial load in, say, the columns. So I can just click on that, and you can see the loads in the columns there. You can see how they're reducing as we go up the building. Okay, you can clearly see the results there. You can filter out, so if you just wanted to look at a particular floor, maybe I'd like to see the second story there, I can just come and look at this in more detail. I may be interested in looking at the shear or the bending, and you can look at this for individual load cases here, or you could look at it for a particular load combination of your choice. So you can just come in and interrogate this to suit. Now earlier you would have seen that I used rigid zones, and what we've done here is build out rigid arms out to the face of the column and the beams. And what this allows us to do is design a little bit more efficiently than we would be able to otherwise. So we're able to take moments of face of column, face of beams, and use those for slightly more economical design. Now, if you'd like to at this point, just come back and maybe you want to see the whole building. Okay, I'll just turn off the results. You may be interested to see how it's performing under lateral cases. So I'm just going to show you the displacements under, say, seismic. And you can animate this so you can see the buildings swaying back and forward there under those cases. Okay, and you can also look at the modal behavior. My initial period is actually a torsional period. It's not ideal for this type of structure, but you can see the behavior there. And I can look at the fundamental period in X and Y direction. Okay, so you can see the dynamics at play here in X and Y, and you can look at higher mode shapes here that are being produced by the software. Okay, so you can look at how the behavior is being created there. Okay, so if I'm happy with that, we can then move in and look at the design. So you can see here that we've designed a number of the elements in the structure. If you just click on, say, a column, okay, you can see what's critical in terms of design. In this situation, it's actually a gravity case that's governing. And we can look at the design here. So you can see we've automatically calculated the neutral axis here, and we've designed this based on looking at capacities based off the lever arms that are generated from that neutral axis. And there's detailed design reports here, so you can see the various checks that have been done to satisfy the code. Okay, you can also look at interaction diagrams here as well, so you can see we've cut a slice through this at the critical case, and you can see all the different combinations that are being checked here as well. Now there's different limits, so you can see seismic limit, axial limits are all plotted there as well. Okay, so we will then be using those to check in accordance with the code. Obviously, gravity cases may have a different axial limit from seismic limits, so they're also defined there. Now, if I come out here, I may want to come and look at the beam design. Okay, so let's just click on the members, and you can see that the members are designed here. You can come in and click on a particular beam. You might see there that I've got one member that just maybe I've got a little bit of axial load in that, so it's flagging that to me. So you can set up limits in terms of what you would expect to be acceptable or unacceptable loads that we don't cater for in design. So minor axis bending, for example, axial loads and beams are not normal. So what we do is we'll flag those to you. But this is optimize the design here. You can see a schematic of the reinforcement. If you click on the diagrams, it will then open up the diagrams, and you can interrogate the results here. So you can see that we've created envelopes here. You can look at the envelopes created there, but you can also look at individual locators here. So if I want to look at dead and live, or maybe I'm interested in seismic, okay, or seismic combinations, you can just come and view these in here and look at these in more detail. But what we do is we wrap all these up in envelopes, and then we will use these for the design. Now you can play with these if you wanted to know if there's any torsion in the member, or perhaps you're interested in deformation. Maybe you don't want to see shear and bending. These diagrams are dynamic, and you can just adjust these to suit. So I might be interested in, say, relative displacement of the member. I can click on that, and then I'll get those results here. So these are adaptable, these diagrams, and these can be adjusted just to suit what it is that you want to see. Okay, so I've designed this. Now, the other interesting thing about this is that these are dynamic. So I can come in here and make changes. If I decided that I wanted to change rebar arrangements in here, I can. If I make if I reduce it too far, you can see that we're live checking this. So instantly it's told me there that I don't have enough steel involved in my beam, and my steel doesn't meet the minimum code requirements, and the spacing requirements are also not satisfied. So this is dynamic, and this is live, and you can just work with this to suit the way that you might want to see things eventually detailed. So this is up to you. You can come and adapt this. Now, even at this point, even before I get into the detailing, we can just come and preview what that might look like. So you can see here, I've just done a quick preview of what that actual detail might look like before I move to actually creating my drawings. Okay, so that just explains to you a little bit about the member design, and we can look at some other things for the steelwork as well. At this point, though, I'm just going to come down to the foundations, and I just want to come and work with at the foundation level. So to do that, I'm just going to let's just come down to level 0, and you can see our foundation view is here. Now, at this point, I may just want to select some columns at the periphery there, and if I right click here, I can just come in and insert a pad base or perhaps a pile cap. So let's choose a pile cap, and we can move in here, and you can see it's opened up the pile cap menu. There are settings in here that can drive things like the ultimate capacity of the piles, perhaps the way in which you want to space the piles. All this can be set here. And you can then ask the software to design this. So it's now batch designed pile caps for me. It's worked out the number of piles and all the parameters. I can group these as well, so also at the same time find what's similar. And if I hit OK, you can see that the foundation, the pile caps here have been created in the model. Okay, and you can see that I'm visualizing these in 3D as well. Now there's other foundations in here that you can consider. So if I come down, if I look at this column in particular, we could perhaps at this point insert a pad base. That can also be keyed in, so you can key in some properties here. We can calculate this. Maybe I want to use a square footing. That's been created. Now you can also move these around. So if you've got a slightly eccentric foundation, you can create this as well. Okay, and then that's designed, and then you can then visualize that within the model. Now, what if we've got some other unusual types of foundations? So here, maybe I'm wanting to take these two elements. So maybe this column, these two columns. And if we just right click, we have the option to combine these. So I can then use the combined results of these columns to design foundations here as well. So if I right click again, I could insert a pad base or maybe a pile cap, and we've now combined the results for this, and we can design this, okay, and then it can use those combined results to design that particular pile cap. Similarly here, I may want to come and select these two elements, and I'll combine these again, but this time round I may want to create a combined pad base. So again, we can key in the properties. It will calculate this out. All the loading will be merged, and then we can create that foundation type as well. Now there are some other foundation types I'm just going to work with here. I may also want to put in, let's just create something a little bit different over here. I'm just going to come and put in a beam, okay, and we can model a beam in here, and if we just, once we've created this beam or foundation beam, if we right click, we then have the option to insert, say, a strip footing. So let's come and define a strip footing in here. I can work with properties here and create different widths. You can also put in tapers, and you can ask it to design this. You can step through different spring stiffnesses for the design. Okay, I've probably got to work with this a little bit, but to create what it is that I like. You can see it's doing the design now. Okay, and if I'm happy with this, then I can come and create that pad base. So let me go back. I'm going to change this again. Let's come in and put in a wider footing. Okay, maybe let's make it maybe 1200. We can increase the footing depth. You can even come in and taper these. Okay, and you can also even have slightly eccentric arrangements. So it's an iterative process. We will move through and just look at the way in which this can be designed. Okay, and then once we're happy with this, then we can then visualize this in the model. So you can see here I've created a strip footing there. Okay, and I can move through and design that as well. Now the other types of foundations I'm just going to touch on quickly is a raft foundation. If I come down to here, we can insert rafts. I can choose some thicknesses here, maybe it's 500, and then we can define a raft in the model. Now you can also, if you wish, cut strips through this for the design. If you found that that wasn't satisfactory, you could also have the ability to be able to insert arrangements for piled rafts. So if I just key in a pile spacing here, you can see that I've actually now created a piled raft. These pile properties can be manipulated, and you can also play with them. So if you want to remove piles, move them around, all those types of things, you can just adapt this to suit. Now once we've done this, and I won't go into it just in the interest of time, but you can move in at this point and run an FE raft foundation analysis. You can cut integral strips through for the design of the reinforcement, and you can also perform punching shear checks here as well. So all of this can be done within the foundation model, and this gives you the ability to be able to design quite a wide range of different foundation systems.